What does it mean to be intelligent? It is a tough question to which Professor Leordeanu and his team try to answer through their research work. We know by now that intelligence is the property of living things to adapt and to solve problems and even to change themselves in order to survive. What does it take to a computer to do the same thing? Keep watching Research in the Spotlight to find out how computers can learn new things, how they can do it being unsupervised by a human being, and what is the social impact of such a performance. If you were to explain to a 6-year-old child what is the future of learning, what would you say?
Well, this is a very nice question, because this question could be answered in several ways, at least in 2 ways. One, because the 6-year-old child doesn't have the experience we have, so I would have to adapt my language to that level of experience. And second, this is a great question because learning starts early in life. So I hope the future of learning in general would take that in consideration more and more. So I would tell him that probably the future in learning will be more adapted to this natural way in which we learn, and the project in which we are involved is addressing this question in a computational and fundamental way. So I would tell him, my dear friend, please ask your questions. Don't be afraid to ask questions. Ask why all the time. If you are curious about something, be courageous. Discover as much as you can, but also be careful, because the world could be a dangerous place. So, try to be safe and listen to your professors. And also I would tell his professors to let him discover, let him play, let him ask his questions. And this is a process that's, the self-discovery process through which we do the learning. So it's an unsupervised learning, but it's also a naturally unsupervised learning, or self-supervised learning in combination with the universe that tries to teach us so much. So we should let this process be natural, because we are geniuses at learning when we are children. So we should develop this, not stop it in a more in too much formality and too much rigidity.
What do you think is the main threatening to education in 2021?
Main threat to education, and I'm assuming here we have to take in consideration also, not just assuming, actually we do have to take in consideration the pandemic that is going on right now. So I think that one of the problems that could appear is the fact that people start to disconnect from each other because of these restrictions, which make a lot of sense, but at the same time they could pose a danger that we are less and less communicating directly to others, which means that we could lose the skills of communication. That's one thing. We could start diminish our empathy towards others. We could feel less comfortable in the company of others. And learning and the development in our life is strongly dependent on the connection with others. I cannot understand myself completely until I understand another person. And at the same time, I can understand another person until I understand myself. But this is a dual process with communication going both ways. So if all I do is stay on Zoom all the time and sometimes even turn off my camera, it's only a voice, it's really strange. I think that this is one of the main potential threats to education, the fact that we do not meet in person.
What should people know about unsupervised learning?
In our field, in artificial intelligence, unsupervised learning is a very tough problem, very important problem. It's a problem that becomes more and more important in practice, because what does it mean? It means having a system that learns by itself. So what is unsupervised learning? It's exactly this process of discovery in this world, in the same way as our 6-year-old is playing and discovering by himself. At the same time, once in a while, he needs guidance, he needs supervision. And this happens in our automatic processes too. Once in a while, we need guidance from human annotators, we need guidance from engineers, we need guidance from specialists. And in all our projects, we do that. We don't just let machines do whatever they want. But the less we need that, the more they are truly intelligent, the more we actually start understanding what intelligence is. So it's this process of discovery, finding out the new, because in order to find out what's truly new, we cannot just use what we already know. There is something mysterious here. It's the process of discovery, when I can fundamentally learn something new that I simply don't know yet. So that is a very deep question. So I think everybody would be interested in finding that out.
And what does it mean to be intelligent?
This is another of those very tough questions. If I knew the answer of this, probably the problem would be solved, but I could say a few things about intelligence. Some people, we could see features of intelligence that we can recognize. Intelligence is the one that solves problems quickly. Intelligence is the one that solves problems efficiently. With fewer resources, finds the best solution. So we have efficiency, we have robustness in front of noises and in front of difficulties. But the question now comes, okay, so what? Why is this intelligence for? Who is intelligent? Well, if we're looking around in nature, intelligence are the living things. Living beings are intelligent. Why are they intelligent? Well, because they need to stay alive. They have so many problems to solve to stay alive. So one of the main problems that intelligence has to solve is stay alive. Intelligence is the property of life. Life is intelligent. And that connection maybe is not that made yet in our field, but I hope and I feel it's going to be made soon. Because intelligence is the property of living things to adapt and solve problems, to change themselves. A living thing should be able to save itself, change itself, to have this cycle of survival going. So that is intelligence, is the key to preserving life, is the key to survival.
You are now part of a collaborative project funded under the EEA Grants. How did the idea of your project come about?
Well, so the idea of the project is basically trying to understand unsupervised learning in the context of space and time, meaning in our field, meaning working with videos, working with any type of data that comes in time. It's not just, independent images, which was the traditional way of doing computer vision. So my field is computer vision. We're looking at images, we're looking at videos and trying to understand at a semantic level what is going on, what is seen there. Basically, we are trying to solve the problem of seeing, of vision, at first trying to get to the level of human beings. So what is a human seeing in this picture or in this video? So traditionally, computer vision was addressing this problem at the level of images for several reasons. One of them is that computers at that time were not as powerful as today, so they couldn't work with videos because videos require a large capacity to store and to compute. But time and space are linked, are fundamentally linked. And I realized that, and I told myself, I'm never going to think of single images anymore. In my field, in my research, I will always keep these two things together. I have to change my own way of seeing computer vision in my research, because everything happens in time, everything changes. It's a process. It's not, if I'm looking at an object, there are things changing in that object. If I'm looking at a person, I'm actually looking at a living system. It's a process, not just one fixed thing. So time and space are linked, and I think that we should take advantage of this consistency and continuity and constraints that time and space give us by the laws of physics in order to help ourselves learn. Because there is a logic in the way moment t is followed by moment t plus 1 and so on. So if I take advantage of this consistency, then I could easier solve the unsupervised learning problem. So space and time, that is why I chose this direction. Then why unsupervised learning? Well, this is a fundamental problem. It is probably the main reason why I started a career in this, why I went for my PhD. I remember my first paper as a PhD student in 2005 was exactly addressing the same problem. It was actually called Unsupervised Learning and Object Features from Video. So, and it was, again, in video, it was using co-occurrences between parts of an object to discover objects as clusters of things that co-occur together and stick together somehow. So there was, again, this co-occurrence, this consistency in space and time. And now when I'm looking from this paper in 2005 until today, there is a continuity in the development of the ideas that I created together with my collaborators. And today things start clicking, and all of a sudden I said, okay, so now is the time to address this problem at a larger scale, at a fuller scale, unsupervised learning in space and time. This is what project is about, plus all the applications in the real world that follow, in robotics. Like we are using drones in this case. also as an excuse, in some sense, as a way to gather data and to put everything together, but also they are useful, and not many people try to do intelligent drones. More people work on self-driving cars, which is more dangerous, more complicated, it requires a larger amount of money. But with drones, you can do stuff that you cannot do with self-driving cars. You can explore the world. You can go in places where the human cannot reach so easily. I thought about this project as a way of putting everything together, from the practical side to the theoretical side, in AI and robotics. And I think that I think that this is something that we need, not only in our field, but in the society, because AI becomes this very important. It's a very important subject.
What do you think would be the place of AI in our lives 10 years from now?
Well, there are many people making all kinds of predictions regarding that, and I remember a book that comes to my mind. Probably our readers, our viewers are familiar with Ray Kurzweil. He's writing great books about the future of AI. And the book that comes to my mind is The Singularity is Near, in which he's actually proposing this idea that humans and technology will merge. I think that in 10 years from now we will learn. So on one hand, if I'm looking only from the perspective of artificial intelligence, I think that on one hand, artificial intelligence will become closer to humans. It will look more human. If we're looking at the devices we are having today, I think that we see this artificial intelligence and technology becoming more and more friendly and somehow closer to what a human needs and what a human is. Let's look just at the phone, how a phone looked 30 years ago and how a phone looks now. It's not even a phone anymore. It's everything, and it's very friendly to our needs. Really, I think that this is clearly a way in which artificial intelligence will move, in being friendlier to us and empowering us to do things that otherwise we cannot do, like an exoskeleton, if you want, that gives us these extra powers.
Which are the main research hypotheses of your study?
The first questions, the fundamental questions of this project go from the basic ones, the fundamental ones. What can be learned in space and time and space-time consistency? What can I extract from that without a teacher? The second one is how I can put together several interpretations, and by finding this consensus, use that consensus as the teacher. Not a human teacher, but actually a rigorous way of in a mathematical way of putting things together, and be guided by this consensus in order to learn. Third, how can I use these ideas in a practical way and show it on a system, like have a drone that flies, understands the world by itself, is able to find out where there is a safe area to land, is able to understand its environment, understand the obstacles, make a difference between a person, a living being, or a tree. This is important for a drone that might lose contact with its pilot. Okay, so these are the hypotheses. Can we find those principles? Can we have a mathematical formulation of those? Then can we prove in experiments this? And then how can we take these ideas, move them towards technology transfer, towards the market or towards the industry or a company? Can we change the world with this?
Are there any partial results that you would like to share with us so far?
Yes, of course. We have several very interesting results that we can share with you, and they are shown in our recent papers, which we published. We also have some demos, which I would love to show you. So this is the result of our algorithm, which was published last year. And then, of course, we have other papers on the task of depth prediction. So it's a lot of mathematics, but at the end of the day, what you'd want is something like this. So what we are doing here, this is a scene, right? And instantaneously try to predict depth, like how far is each element in the scene. And with darker blue, you can see things that are closer away, and with brighter colors that are farther away. So we have different methods here that we compare with, but this is the idea. And you want to do it as fast as possible, and you want to do it as efficiently as possible. So you have this drone or this robot that moves really fast, let's say, and is able from a single frame or two frames to tell how far things are. So I would say that I'm extremely happy at the level that we reached in about 2 years of the project. So we are better than I expected, I would say, regarding the results. And I'm very confident that in 2 more years, until the end of the project, we will reach the level that I wish to see, in which we could put everything together and maybe even have this move towards industry. So one result, for example, is that we showed that we could have minimal human annotation in a video for semantic segmentation, for understanding what's in the video, and then propagate that in an automatic way to other frames in the video, which is really important for having automatic annotation, which we can use for supervised training of our models. Then we also showed this consensus system with several tasks, several interpretations. We actually have several papers already accepted and published in this domain, in which we have basically what we have is we see the world from different views, semantic segmentation as a depth, movement, position, edges of objects, and how can we interpret one interpretation, how can we predict one interpretation from the other, and have this graph of multiple interpretations, and have actually a principled way of computing consensus. People use this word in a very relaxed way, but is there a mathematical way of writing this consensus and use it as an objective function which you can actually optimize in a computational way? And we showed you can do that, and it improves learning, unsupervised learning. So we already have that. Now, of course, we have another paper in which we showed how, and this was really interesting, how this consistency in space and time ends up being the same as computing the eigenvector of a matrix. Now, if someone would told me that when I first learned about eigenvectors, that this could translate immediately to a problem seemingly unrelated, like object discovery in video, I would say, wow, I don't see the connection.
How did the pandemic influence your work so far?
Of course, that I was affected by everyone else. I was doing my best to stay strong and not to be affected in a psychological way that much. So on one hand, there was the advantage of working from home. The advantage, why? Because I didn't have to travel so much. So in some sense, I was becoming more efficient. I was actually being able to do more. But at the same time, as I told you, it's important to communicate, to meet people, and I miss my students. I miss meeting them. There have been students that I have not seen them in person for 1 year and a half. When we met, of course, we were lucky we were seeing each other on the internet when we were talking and doing research. But it's kind of strange not to see people. It was this moment when I felt that it was almost awkward to meet people. This is really strange and sad, not to be able to feel strange to meet someone, to feel strange to look at someone's face and say, oh, you don't have a mask. I don't see your smile. I cannot communicate with you very well.
Your research is part of a collaborative project which involves an international research team and a partnership with different research organizations from Norway and Romania. What does it mean to you and to the team you are part of, such a partnership, and what are the benefits, in fact?
So we are, I see this as an amazing opportunity to be able to collaborate with our friends and colleagues from Norway. First of all, I want to thank Norway and Romania for having this amazing partnership and giving us this chance to do the research and collaborate with the group from Norway. So we are collaborating with Norce, some wonderful, very wonderful people there, and we have already started a real and nice collaboration on several levels. So not only that we have weekly or bi-weekly meetings regarding the research projects that we are working on and planning papers together. We also did several projects, like we organized a workshop at a top conference in computer vision. It was a pretty good success. Then we continued in the next year. And now this year, I organized together with them an autumn school for machine learning for industrial applications. I just presented 2 weeks ago, I think, and it was well received, what we have done here in Romania. At the same time, they have this very interesting environment in Norway, which is very different from Romania. And they can give us very interesting data to test our algorithms on. So I think there is a nice combination. Plus, they have many more drones, more powerful drones. They have a huge institute there with for exploration of that environment, which is very, very interesting. So there are many things to explore there.
Speaking about plan, what are the next steps in your research?
So the next steps is now to put all these modules together. So we are at the level in which we move all this research from the fundamental level to more the real world level. And this is the next step, to put it in the real world, to test it, to see what's missing, solve the remaining problems, such that in 2 years from now we can say, okay, we have this autonomous robot that can learn by itself in this context and can discover things with minimal human supervision. And then also have this in Norway, go there hopefully, see these systems work in that environment where you can, it's completely different. They have, they're filming penguins, they're filming all these wildlife, glaciers, and all these classes of things, as we call them, different scenarios and scenes which we do not have access to here in Romania. So I would also like to see that.
In the end, what should people remember about your project and about its social impact?
If I had to speak to a general person in the population, let's say, I think what they should remember is that we are trying to solve one of the most interesting problems that humanity or sciences have faced, which is what is intelligence, what is learning, what is discovery. And if we manage to do that, and I think we're on the right track, I think there is no person in this world who would not be interested in and would not understand the results of our project. I think this is the beauty of it, that anyone could understand once we solve it. And once we pose the question because this is a natural question. This is a question that comes to everybody's mind. What is consciousness? What is intelligence? What does it mean to be intelligent? What does it mean to learn? What does it mean to discover? Now, if we can show a robot that can do that, if we can show a system, an automatic system that can do that with clear results, and I'm lucky to work in robotics and computer vision because it's easy to understand the results in these fields, anyone would be interested. The social impact is immense. Because everyone is interested in it, that's for a good reason. Once I know what intelligence is and how it evolves and what principles are the basics of this phenomenon, I can improve all fields, right? I can improve AI, and once I improve AI is connected to all the other fields, because in every field you need to make smart decisions. You need to save energy and to adapt to the specific situation. That is intelligence. So all these fields in industry will be, and agriculture also, and medicine will be improved by solutions in which you can learn a system can learn by itself without human annotation. This will change our society, and I hope only for the better, because we will have more power. And as I said, we should be not just more intelligent of how to use this power, we should be also more ethical about it. So, of course, new ethical questions will arise. So the society will change in all its aspects, from law, the legal aspect, to technology, to everything. I don't think there will be any part of our lives that will not be affected. Some people connect artificial intelligence, and I heard many people making this connection. It's a metaphorical connection, but it came to my mind before I was reading about it, is that artificial intelligence is like electricity. Once it's discovered, everybody can use it, and it's changing the world. It's really at that level. It's almost like electricity. Electricity is at the basic level. Artificial intelligence is on top of it, but they will be together.
Thank you for watching Research in the Spotlight, a podcast for scientists and passionate science people made under the EEA Grants research program by the Executive Agency for Higher Education, Research, Development and Innovation Funding as program operator. Until the next time, like and share this episode if you think science is our key to a better future.